Okay, welcome 20-3, and let's get right into chapter 4. So this is going to be trigonometry. It's only actually two parts. So there's this one and then 4.2, and that's it. And even 4.2 is just a little bit tougher. So it's kind of it's going to be a shorter one, hopefully. Okay, so what we're dealing with is triangles, right? That's what trigonometry is. Just so you remember, for a triangle, you've got the hypotenuse. That's the long side of the triangle. You've got the adjacent side, that's what ADJ stands for, and you've got the opposite side. And if you need a way of remembering those, here's the angle, right? Opposite is on the opposite side of the angle, right? It's like all the way over there. The word adjacent means beside, so adjacent is beside the angle. And then hypotenuse is always the long one, however you gotta remember that. You've also got a formula sheet where I've kind of just taken a picture of this and even put it in here. So if you need this to remember, and then we're going to use these trig ratios in a bit, and then here's the old Pythagorean theorem too, if you can't remember how to do that. So you're going to want to be looking at that while you're doing these probably. Okay, so let's just get right into it. So I'm going to let you guys actually look through this page, so 198, right, and look through these examples because it gives you the answers here, so it's good to look back to help you out. Oh. And then the next page too. I don't know what that is, why that didn't really turn out right. But anyway, so you can look to that to solve those two. But let's actually just start on these ones and do them together. So number one says find the value of the indicated trigonometric ratio to 4 decimal places and calculate the angle. This is called theta, is what we call, that's the Greek name for that. So the angle theta to 1 decimal place. Okay, so trigonometric ratio. It's not too bad. So tan theta, so it's saying the tan of whatever the angle is, that might be like 30 degrees or 20 degrees or something like that, right? So tan of the angle, we don't know what it is yet, is going to be equal to, and now just look to your formula sheet, and you can see that tan theta is equal to opposite over adjacent, right? The one down here. So, go back to your thing. Tan theta is equal to opposite over adjacent. And by over, I mean divide, right? So all we have to do here is just make sure that we've got our opposite and our adjacent figured out. So if this is our angle, opposite side is going to be opposite to the angle. It's going to be over here. The adjacent one's going to be on this side. So this is the adjacent, this is the opposite. So now we just need to make sure we put those numbers in our formula properly. So we keep working downward, right, as we're writing this out. We write tan theta is equal to, the opposite was 7.9, our adjacent was 12.3, and then literally just in your calculator, you just need to go 7.9 divided by 12.3. Because the question said find the value of the trigonometric ratio. It didn't say find out what this angle is. We're going to do that in a bit. All we need to figure out is what the decimal of these two numbers divided by each other is. So that's all we're going to do. Just go 7.9. 7.9 divided by 12.3. So 0.642, and then round that to 3. So 0.6423. Okay, and that'd be the first one there. So that's the ratio to 4 decimal places. And then it says, and calculate the angle theta to 1 decimal place. So we figured out that part. The next thing we got to do is we're going to write tan theta is equal to, well, we just figured out what it's equal to. It's equal to 0.6423. Now the next one we're going to have to do in our calculator properly. It's just making sure we kind of got that figured out on your calculator. They're all going to be a little different. And just before you do put in your calculator, I just want to write it out what the way this should look if we're looking for the angle theta. So the next step, you go down and say, okay, the angle theta, without the tan attached to it, is going to be equal to tan, like the inverse of tan, that's what that -1 means, and then times, or not times I guess, but tan of this ratio, so 0.6423. So that's what that's going to equal. That's the proper way of writing it. If you don't really get this and like what that all means, that's okay. We just need to know how to put this really into our calculator properly. So you just need to write theta is equal to, if you're kind of looking back up to that spot, theta is going to be equal to And then we need to find this in our calculator, tan inverse 1. So on your calculator, one sec. You should probably even still have this in your calculator, right? 0.64 and then this whole like huge long string of digits. Yours might not look that long depending on your calculator. So you have that in there. Remember what that was. That was just going 7.9 divided by 12.3. That's how we got that. Now, on your calculator, you should have a shift button that, might look like this. It might say shift. It might, there's a bunch of different ways it could look. But then it's probably going to be attached to your tan button because it's the inverse of tan. So you can see if I push the shift button, it changed my tan to tan -1. You might have written above your button, like in yellow or something, the same thing. That's what we need to do. So we need to take that number that we did, and then go shift, and then tan -1, and it just pops it right out at us. So it's 32.7 is what the degrees actually would be. So this is going to be 32.7. Hopefully that made sense. We're gonna get good at it. All right. So now this one, same type of thing going on here. We're gonna say sine theta. Look to your formula sheet. Sine theta is equal to opposite. Opposite over hypotenuse. So write that down. Okay, opposite over hypotenuse. Now we just gotta put the right numbers where they go. So sine theta is equal to, well, the opposite here, opposite to the angle, is 1.8. And then the hypotenuse is 2.3. So opposites, we're going to go 1.8 divided by 2.3. Okay, and then sine theta is equal to 1.8 divided by 2.3, 0.7826. Okay, so that's the first part. The second part says we need to find out what the angle is. So I'm going to say sine theta is equal to 0.7826. And now you just got to do that thing in your calculator, right? So theta is equal to sine, the inverse of sine, 0.7826. And then if you put that in your calculator properly, it's just going to be, I've still got the number even in there. So I'm going to go second and then find, oh, it was already on there. Second. And then sine -1 is the thing I'm after. And it says 51.5. So it's going to be 51.5 degrees. Oh, and I should have put degrees up on the last question too. A little symbol like that. Okay, that's it. So I'm going to let you guys go ahead and try C on your own. Okay, so go ahead and answer 1C now. Okay, number 2. Find the height of the triangle to 1 decimal place. Well, one little clue we can use for this is that there is no angle that they're even mentioning here, right? There's no angle like there was in the last one. We've just got 2 sides and we need to find the other. So this isn't really anything to do with our trig ratios, like the ones we had over here, over there and stuff. It's going to be Pythagorean theorem. We've just got 2 sides and we've got to find the other. So let's just write out Pythagorean theorem. So Pythagorean theorem, we said, was a squared plus b squared is equal to c squared. On your formula sheet, it's written as h squared instead of c. It doesn't matter what you call them. It's just the hypotenuse is going to be what that is, right? So we're calling this c, this a, and this h we'll call b, just to keep it simple. Okay, so there. So we're looking for b in this equation, right? Is what we're after, because this is c and we got it. So if you want to just fill everything even in from there, we can say, so a squared, so we're going to say 10.6 squared plus b squared is equal to, oh, and we know what c squared is. So it's going to be 19.8 squared. Okay, so if we're looking for b, if you're ever looking for something that's not the hypotenuse, the equation just turns around and it's going to be b squared is equal to those two subtracted from each other, and the big one minus the little one. It's going to be the hypotenuse minus the other one. So it's going to be 19.8 squared minus, instead of plus like it was up here, that was to find the hypotenuse, right? We're not looking for the hypotenuse, we're looking for one of the sides. So we're going to subtract instead, and then it's going to be minus 10.6 squared. Okay, b squared is equal to those things, so let's go, so we'll go 19.8 squared. Your guys' squared buttons will all look a little bit different. I'm going to push the shift because I think that's where it went. Yeah, so x to the 2 is the way it usually looks. So x, so that's going to be that minus 10.6, nope, not 106, 10.6 squared. And you can see it even kind of kept track of it up here, right? And then I got to push equals. So that's what that equals, is 279.68. Okay, so that doesn't make much sense though, right? 279.68 is being the length there. That doesn't even kind of like, it's not even the same ballpark as those numbers. Well, what we have to do last step is take the square root of both sides. So if I want to figure out what b is equal to, we got to take the square root of both sides. And what that did is square root of b squared, they cancel with each other. And then this will just be our answer. So the last step, we just need to go square root, and that's that little symbol right there, right? So that, and it's equal to 16.7 centimeters. Okay, and then that makes sense, right? That's a number that looks like it would belong there. It's in the same ballpark as the other two numbers. Okay, so that's how you do those. Okay, so now we are getting into some, like really the same thing. We're using all the same things, those two things we just learned. But now it's just getting a little bit more complicated. Got some more, like you can see in this one, we've got like 3 triangles going on there. Or 4 really, if you take the whole thing as a triangle. So then we just need to kind of piece that together. Yeah, so you can look through that one just like last time to kind of look how they solved it. So that, but let's do 3 together here. Okay. Okay, so for these ones, we're going to have 2 steps that we got to do, though. So, what we're after is x, right? That's the thing we're after in the end. And we could find that if we had, let's say, this side and this side, we could find it. Or if we had this and we had the angle, we'd be able to find it. You pretty much need 2 things and you can find the third in any triangle. But we don't have those things. So what we got to do first is figure out the thing that's connecting the two. So that's this length, right? The length of that side is the same for this triangle and that triangle. All right, so how do we find that? So let's, if we called this, so here's our angle. 19 is going to be our adjacent side. So that makes this our opposite side of our triangle, right? So look back to your sheet there, and we can see, okay, which of them deals with opposite and adjacent, right? Well, that's this one. Tan theta is equal to opposite divided by adjacent. Okay, so let's write that down. So we'll write down tan theta is equal to opposite over adjacent. Okay, now let's fill in what we know. So we know what the angle is. It's given to us right there. So let's fill that in. So we'll write tan of 35 degrees is equal to, the opposite is what we don't know, so I might just replace that with like a, maybe, or just leave it as opposite, it doesn't really matter. Call it like a y, or, I'd say x, but this one's already called x, so anyway, so leave it as opposite. And then adjacent, we know what that is, that's 19, right? That was this side of the triangle. So, all you gotta do then is get opposite on its own, right? And the way that we'd really do that is we'd multiply both sides by 19. So we go, this side by 19 and that side by 19. And so 19 on this side, 19 on this side. They'd cancel. So 19 times tan 35 would be equal to the opposite. If you want a little bit, maybe a little bit easier way of thinking about it, I've kind of shown some of you guys this, that if you go opposite over 19, like we had, if you write tan 35 over 1, then what we can do is just do our cross multiplying thing. So if you've got 19 in the bottom, it will be 19 times tan 35 divided by 1 will give you the opposite. So it's that cross multiplying piece of it. So 19, so let's proceed there, let's start over. So we'll go 19 times, and then just go, usually in these kind of calculators you have to go 35 and then tan, not tan 35, usually. Unless you've got a bit more of an advanced one, then it'll be tan, and it'll show you that you can put 35 in for it. But it'll just be 19 times, and then you'll write 35 tan. So you can see up here what it did, right? It said 19 times tan 35. And then don't forget to push equals. So that's going to be equal to 13.3. So the opposite side here we just figured out. So here, I'll write this down too. Opposite is going to be equal to 13.3. And that's what this side is. 13.3. The length from there to there. Okay, so we got that figured out. Now, this is just a Pythagorean theorem problem. We've got one or two of the sides. We need to find the hypotenuse. Well, a squared plus b squared is equal to c squared. So we have a and we have b. You could call those either ones too, right? You could switch a and b. Doesn't matter. But anyway, so let's write down. So we got 33 squared plus 13 squared is equal to c squared. Okay, so if you put those in your calculator like we showed before, you should end up with 1,265.89, let's say, is equal to c squared. And then the last thing you have to do is just take the square root. So square root, both of those, so that gets rid of the squared there. So c is going to be equal to 35.6 centimeters. So there's your final answer. Okay, hopefully that wasn't too tough for you guys. All right. So, same type of problem here now. Calculate the measure of angle theta. So now, it's another one of these puzzles, right? They've given us this length here and this one here, but we don't have enough info. We do know that this side is 8, right? What we're really after is to have two things, and then we can, on this smaller triangle, and then we can figure out what the angle is. But we've only got one right now. We know that the opposite side is 8. So pretty much we either need to figure out what the hypotenuse is first, or the adjacent side, what that to that is, to figure out this one. So, actually, I kind of lied to you. The other thing that we can do here, that's actually going to be a lot easier way to solve this, is we're looking for this angle. We're looking for, so we're looking for that angle. We know that this angle here, right, they're saying that that's 90 degrees. So we know that that's 90 degrees, if we're looking at the whole triangle, the big one, right? So if we figure out what this angle is, do you know what all of the angles on a triangle add up to? Well, they add up to 180 degrees, right? So if we go, yeah. Anyway, so that's what we need to figure out. So if we figure out those two things, we'll be able to figure out the last one because we know all the angles add up to 180. All right, so first off, we need to figure out what this angle is right there. And the way we can figure out that is we know the tan ratio. So tan is equal to opposite over adjacent. Okay, oh, and tan theta, sorry. So tan theta is equal to, well, opposite in this case is 8, right? It's opposite of the angle. So it's going to be 8 over 11. Adjacent's 11. Okay, you could, in your calculator, go 8 divided by 11 first. I probably would do that too. So if we're going to figure this out for the angle, what you do at this point is just go, okay, theta is equal to, and it's going to be tan negative 1 of, now you can either write this as a decimal by going 8 divided by 11, or leave it as 8 over 11. They mean the same thing, right? So then the angle is equal to, so in your calculator, you're going to go, start over, we're going to go 8 divided by 11. That's equal to that decimal there, right? 727272. Okay, and then the last thing you got to do is just go shift and then tan negative 1. And our angle here is going to be 36, so 36.0 degrees. So we'll just say 36 degrees. 36 degrees, yeah. Okay, so that is this angle right here. We now know this is 36 degrees. So I know all of the angles need to add up to 180. So let's go, so 90 degrees plus 36 degrees plus whatever that angle is equal to 180 degrees. So if I want to figure out what that angle is, all I need to do is go 180 degrees and then subtract these ones. Subtract everything else. So if we go that minus 90 degrees minus 36 degrees, I should end up with what's left, and that's that angle. So 180 minus 90 minus 36 is equal to 54 degrees. Okay, moving on. Okay, so I'm actually going to let you guys do number 5, but I'll kind of walk you through the process. So it just says find each of the indicated sides. So we need to find x, so the distance from there to there, and y from there to there. Alright, so we just got 2 triangles there. First off, what I would do is find x. So that's the first step I would do, because that's going to help you find y. So finding x here, if we broke down what kind of triangle you have, you've got, if you're looking at the smaller part, or the smaller triangle here, we've got, this is our adjacent, x is just our hypotenuse, and that's all we really need. So which one of the ratios on your sheet deals with having adjacent and hypotenuse? Well, cosine, right? So you're going to start off by writing cosine, just write the equation out, cosine theta is equal to adjacent over hypotenuse. Okay, and then just fill in what you know. So cosine of 28 degrees is equal to, we know the adjacent is 6.3 meters. Let's leave that out. And then that's going to be over our hypotenuse, so x. Let's put this over 1, and then remember just the cross multiplying thing. So you're able to go 6.3 times that, divided by that, should give you x. So I'll let you guys go ahead and finish that one. But when you're done, so you're going to figure out something for x. You'll have some number here, right, that you'll now know. Well, that number that you're going to know plus 0.8 meters, that's going to give you the hypotenuse for the whole thing, right? After you do that, you're going to have the hypotenuse. You're going to have the angle, still, same angle, right? But now you're going to be looking for the opposite on the bigger triangle. So then you're going to have to look and say, okay, which one of the tan ratios deals with the hypotenuse and the opposite? So hypotenuse and the opposite, well, that'd be sine. So now we're going to be dealing with sine theta. So in this, the part 2 of this, after you figure out the hypotenuse, you're going to be using the sine ratio for it. Okay, hopefully that made sense. I kind of want you guys just to get your hands dirty trying this one. So carry on from where I've left off there, and go ahead and answer number 5 now. Okay, moving on. So now we're just going to be kind of putting stuff to use here. So now we've got like a piece of plywood that's cut with the dimensions kind of shown here, right? And all we really know is that this side is 6 feet, and these little dashed lines, like dash dash, that means that this is also 6 feet. So it's just kind of showing that those two lengths are the same. That's what the dashes mean. Okay, so that's what we know. You can look through that one to kind of figure that out, but I'm just going to move on to these other ones. Okay. So number 6, find the angle of offset between 2 pipes. How long is the travel pipe? Okay, so this one is just a kind of more of a real world thing, but we've done ones like this, right? It's asking for what's the angle. So the angle of offset, so that's going to be this one, right? And then it's asking for the hypotenuse. That's what the travel pipe in this case is going to be, right? From there to there. So that's just our hypotenuse. So I'm going to let you guys actually go ahead and answer number 6 on your own. So go ahead and answer number 6 now. All right. Okay, so number 7. Now the kind of problem is that we have to kind of make our own pictures first. So it says a woman standing on one side of a deep ravine. Sorry, a woman is standing on one side of a deep ravine. The angle of depression, we haven't really talked about that yet, but we'll get to it. To the bottom of the far side of the ravine is 52 degrees, and the ravine is 120 meters across. How deep is the ravine? All right, so we've got a woman standing up here. Sorry for my bad drawing. And then let's just draw a ravine. Okay, so she's standing on the side of it there, right? So it says the angle of depression. So the angle of depression is just actually the angle. So if we were able to make a line that went like straight out from the side of the cliff here, or the ravine, the angle of depression is the angle that it goes down. So she's saying the angle from her over to this side, over to the corner, this would be the angle of depression right here. So this is going to be 52 degrees. So that's what it's saying. So it's depression. If you think about depression, like to depress something means to like push down. So that's kind of what's happening right there. It's like you're pushing the angle down away from you. So the angle of depression is 52 degrees. And the ravine is 120 meters across. So we also know that this is 120 meters from there to there. Okay, how deep is the ravine? So what we're after here is this, right? We want to know what this side is over here, what that length is. Which, by the way, would actually be the exact same as this side over here. So we can kind of think about it however you want, right? So two ways to handle this, two ways you could do it. You could go 90 degrees minus 52. That would give you this angle, right? Because this is 90 degrees, going straight up and then straight across. So if you went 90 for 90 degrees minus 52 degrees, I would know that this is 38 degrees, right? So then we could just go, we could just use our sine ratio to figure out what this side is. Or we could have kept our 52 degrees and then realize that, well, this would also be 120 meters up top, right? You have like a triangle going on up top too, right? So 120 meters, 52, and then solve for this. You should get the same answer either way, right? Okay, so let's go ahead and just do the red side of the triangle, though. We'll figure it out that way. So if we did that, we could say that we're looking for the adjacent side, right? This is adjacent. And this is going to be our opposite, because the angle is opposite to the angle. Or the side's opposite to the angle, I mean. Okay, so then which one of our formulas deals with adjacent and opposite? Well, it's going to be tan, right? The tan ratio. Tan theta is equal to opposite over adjacent. Okay, and then fill in what we know. We know tan of 38 degrees is equal to opposite is 120 over adjacent is x, so we don't know that one. So if I put tan 38 over 1, we can do our little cross multiplying thing. So just start with 120 and go 120 times 1 divided by tan 38 will give you x. So we'll go 120 times 1, which really didn't do anything, right? Still just 120. And then divided by, and then remember it's got to be 38 and then tan, but I'm still on tan -1, so I got to push shift again. So 38 and then just tan. And then remember, I got to push equals because that number up there is just the tan ratio. So I go equals, and then it's going to be 153.6. So the side length there, I'll just say x is going to be 153 point, did I say 6? Yeah. Meters. Okay, and that's it. Alright, moving on. Oh, before I do actually though, I just want to kind of show you this picture too. So if you're having trouble with that angle of depression thing, or angle of elevation, this is what it means. So straight line, angle of elevation is like up from the horizontal line. Angle of depression is down from that line. So, okay. Okay, so I'm actually going to let you guys read number 8 and do number 8 on your own, because I think it's pretty straightforward with what we've been doing so far. It's a little easy. It's only one step, right? So I'm going to let you guys go ahead and do that. So, yeah, go ahead and answer number 8 now. Okay, so here's example 4. I'll let you guys look through that one too. This one, the kind of key is to make some triangles out of this. But they kind of go through with the textbook too to kind of walk you through how they would go, how they would work. So take a look at that. I'm going to go through though, just for the sake of time. So that's still their calculations there, and then build your skills. All right. So number 9. So Pauline is building a fence around her vegetable garden, shown below. What length of fence will she need to build? So really we're asking for the perimeter all the way around. So like the length, around the entire thing. So what we're going to have to do is kind of make some triangles where you think you could. So I can see right here I can make that into a triangle. And I can make that into a triangle. And what that's going to do is help us figure out what this length is and what this length is. Because we know the rest of them. We could just add that, and the two that we need to find, and then that's the answer. So let's just kind of deal with this one over here. How can we figure out what the hypotenuse is there? So we need that length. Call that h. Well, we first are going to need either this side or this side. And we actually know this side over here, right? Because that's this, 1.75. It gives us the height from there to there. So I'm just going to move that over here. That's 1.75. So now this is just Pythagorean theorem. Let's go h squared is equal to, oh, my bad, not Pythagorean theorem. We know the angle, not the side. Okay, so we'll still call that h. But then we know this angle, that's this angle here, right, 68.1. So now we know the opposite, right, this is on the opposite side, and we know and we're looking for the hypotenuse. So which of our things deals with opposite and hypotenuse? So opposite and hypotenuse, well, that's sine. So we need to go sine theta is equal to, so sine theta is equal to opposite over hypotenuse. Then just fill in what we know. So sine of 68.1 degrees is equal to, the opposite is 1.75, and the hypotenuse is what we're looking for. So let's leave that as h. Write that over 1 if you want, and then we're going to go this times 1 divided by that is equal to that. Okay, so if you do that, you should be able to figure out what h is. Okay, once you know that, we're going to need to find, I don't know, this side we'll call x. It doesn't really matter, right? So find x. You're going to do it in a similar way, right? Just using kind of like a different trig ratio probably, or even the same one, I guess, in that case. And then just add them all together. Just make sure that you add all your sides together, and that should be your perimeter. So I'm going to let you guys finish this one. So you can go ahead and answer number 9 now. Okay, so number 10. Sojin is installing carpet in a den. Using the floor plan below, calculate the area of carpet Sojin will need to buy. Right. What I would do, so now we know 8 meters. I also know this side's 8 meters and this side's 8 meters. I'm going to fill them in now. What I would do is draw a line across there that I also know is 8 meters, right? This is just a big square. So then I can figure out the area of the square really easy, right? I know that the area of a square is just base times height, so 8 times 8. So the area of that, let's even figure it out right now. 8 times 8, write that in the center. 8 times 8 is equal to 16. So 16 meters squared. All right, so we got that one figured out. We got to figure out the area of our triangle now. So the area of our triangle, remember the area of a triangle is just base, so the bottom here, which is 8, which we know, times the height from there to there. And you can see we've just made 2 triangles. So really, we need to figure out what the height is here, right? So we can figure out that height if we need one more thing, right? Because I know that the hypotenuse of this little triangle is 3. I don't know what the length is from like there to there. And I don't really know what the angle is from there to there yet. So, yeah. But we can figure that out because this 131.6, what that is the angle from here to here, the whole thing, right? Well, we've got a line that's going through that, right? And I know that this is 90 degrees from there to there. It's a square, so it has to be. So if I go 131.6 minus 90, I should be left with what's there. So let's do that. So let's go 131.6 degrees minus 90 degrees. 131.6 minus 90 is equal to 41.6. So that's what this is. This is 41.6 degrees. So now that I know that 41.6 is my angle, I have the hypotenuse, and I'm looking for the opposite. So which one of these deals with hypotenuse and opposite? Well, sine. So it's going to be sine theta is equal to opposite over hypotenuse. So sine theta is equal to opposite over hypotenuse. We know the angle, so I'm going to write sine of 41.6 is equal to, we don't know the opposite, so we'll just call that x. So length, side length x, over, and the hypotenuse is 3. If you want to put that over 1 and do your cross multiplying thing, it's just going to be 3 times that divided by that gives you that. Okay, so 3 times, and then remember it's got to be 41.6 and then sine. You kind of do it backwards from the way you read it. So sine and then equals. So 1.99. So I'd even say 2. So x is going to be equal to 2. Okay, so we got the hard part figured out. So the height from there to there is 2. All right, now the formula for any triangle is just base times height divided by 2. And by triangle I mean the whole thing, right? We'll find the area of that whole thing. So let's just do that. So the area, let's do a different color here. So the area of a triangle is going to be 8, so base, times the height of 2 divided by 2 because it's a triangle. So that's just going to be equal to 8, so 8 meters squared. So that's what the area up here is going to be, 8 meters squared. All right, so we know that. We know that the area from the beginning of the whole thing was 16. So the total area, or area total, is just going to be 16 meters squared plus 8 meters squared. So the total area is going to be equal to 24 meters squared. And you're done. All right, now it's time for you to practice your new skills. So they're going to start off a little easier and get a little harder. So I'm going to let you guys answer these ones on your own. So number 1, in each triangle, solve for x. So go ahead and answer number 1a now. Okay, and let's kind of do these all together. So, yeah, so go ahead and answer number 1, B, C, D, E, and F now. Okay, moving on. Almost done, I promise. Okay, you guys can go ahead now and answer G and H now. Okay, number 2. Okay, so number 2, maybe help you out a little bit. We got a ladder leaning against a wall. So there's a wall, and we've got, and there's the ground. There's the ladder going up the side, right? So it says if the foot of the ladder is 1.8 meters from the wall, that means this, the foot's the bottom. So it's just saying this side is 1.8 meters. And then how long is the ladder? So I'm not going to tell you any more than that. So go ahead and answer number 2 now. Okay, 3. A tree casts a shadow that is 12.4 meters long, and the angle of elevation to the sun is 38 degrees. How tall is the tree? So go ahead and answer number 3 now. Okay, number 4. During a plunge, a submarine travels a distance of 350 meters while dropping 200 meters. What is its angle of depression, and how far did it travel horizontally? So let's say we got our little submarine here. There's a little periscope, so you know it's a submarine. Oh, and little windows, right? So we got this thing, and it's saying that it travels a distance of 350 meters. So it's going down, right? Well, it's plunging down that way. It drops 200 meters, so I know that the side length here, let's say of this one, it's going to drop 200 meters. It's how far down it's going to go, right? I could connect that here too, right? So now it's really just said that it travels a distance of 350 meters. That's the total distance it goes like on the hypotenuse of it. So 350 meters. So now it's asking what's the angle of depression and how far did it travel horizontally. So remember, depression means to, like, push down, or like, going down from the horizontal. So I'll let you guys go ahead and answer number 4 now. Okay, and since we've been doing so many triangles, I'm going to let you guys actually skip number 5. So that's going to be it for that one. We'll continue the next one in 4.2.